So there it is, the difference that installing the mod in your dual or triple rectifier will make for channel switching. I'm going to talk a little bit more about how the room was set up, how it was recorded, just to give some more context on that. And that'll be the first part of the video here. Then I'll go and show you how to install the mod in your dual or triple rectifier, talk a little bit more about the mod itself. And finally, the end of the video is going to be like 10 or 15 minutes of going through the schematic of the dual or triple rectifier, seeing what worked out for them, what they tried to do, and what didn't work out. And that's, yeah, that got out of hand. So all the stuff that you might care about, we'll put that up front, and if you have the stomach for it, stick around and we'll go through the schematic for the thing. So, to add more context to the two videos you just watched, the modded and unmodded, it was recorded using an iPhone that's sitting on the desk fairly close to the amplifier itself. Speaker cab is down on the ground. In the unmodded video, you hear a very loud pop when it switches to the clean channel, and then you hear smaller pops as you switch between all the channels, and almost always a pop when you go to channel 2. The popping really isn't terrible, like horrific, unusable, and that's the reason that they were able to sell this amp for 20 years or 10 years, however long the run of this model was. But it's certainly not desirable, and the mod goes and cleans all that up. In the modded video, what you're hearing when I switch channels is me physically stepping on the foot switch. That's just the sound the foot switch makes. And you're also hearing the relays inside the amplifier click over. Like, relays just make a sound when they change state. You're not hearing anything coming through the speaker because nothing's coming through the speaker. Okay, so now, yes, we'll talk about the mod itself. So here it is. Here's the little board that goes and improves the channel switching for the dual or triple rectifier. It works by reading when the foot switch has been pressed on these green wires here, and then activating 3 mute switches in these white wires here. So you can see there are 1, 2, 3 pairs of mute switches. And you go and connect the mute switches, one lead to the audio path, the other lead to ground. A local ground, so ground very close to where it is in the audio path. Apply power through the red wire for the dual and triple rectifier. You'll connect that to +3 volts. Ground to the black wire, you'll connect that to -3 volts. And the mute switches need a +15 volt supply. That's this blue wire right here. So while this is designed to work in a Road King, I haven't tested it in a Road King yet. I did buy a broken one where the channel switching is all messed up. Some component in the channel switching circuit failed, and I'll have to figure out what that is before I can go and try to work this mod into it. Who knows, maybe I'll make a video of repairing the Road King. Okay, so here you can see I've mounted the board in the triple rectifier chassis. It fits nicely over in this section of the chassis. That's over by the clean channel, or the input side of the chassis. It's a convenient place to mount it because all the channel switching is done by this IC right here, and all the connections that you need to make are fairly close to that IC. So you can see that the black wire is connected right there. Now let's get in there a little bit better. So the black wire connects right there to what would have been the minus of this capacitor that they decided not to install. Red wire connects right here to looks like the cathode of this diode. Green wires are connected to the cathode of this diode, which is closest to the channel switching chip, and this other diode, also close to the channel switching clip. As part of the mod, you have to cut the third lead of this BJT. So that's this lead right here, the one closest to my finger. And you come along here. One of the mute switches you connect across the treble and mid pots on channel 2. The other one, the treble and mid pots, on channel 3. The last mute switch you connect across the phase splitter. So that's this lead on this capacitor to this lead on this resistor. That's muting the phase splitter. And then the final thing is add a 2 meg, at least 2 meg, higher value might be okay, a 2 meg resistor to connect this resistor and that resistor. It's basically a 2 meg resistor across the relay that it's sitting on top of. And that's everything you gotta do to install the mod. Okay, so here it is, the channel switching circuit for the Mesa Boogie dual or triple rectifier. We're going to go through this and talk about what all the different things are in it and what's going right with it and what went wrong and caused a whole bunch of pops when you go and switch the channels for it. So it all starts with this LM3914 chip, which they don't really tell you too much about in the dual or triple rectifier schematic. They just give you that pin 17 is going there and pin 1 is going here. They give you a little bit of information about what the voltage will be at these points when channel 1's active or channel 3, but other than that, it's not really too much more. So we're going to go and look at this chip and how it's used in the Road King, because that'll go and give us some more detail. So here we are in the Road King schematic, and you can see how this chip is implemented. So this chip, it's an LED driver chip where you feed it an analog input and it'll go and light LEDs connected to pins 1, 18, all the way up through pin 10 here. I think the idea is if you put 0 volts on the analog input, then pin 1 will be lit up, and if you put 5 volts on the analog input, then pin 10 will be lit up, and in between it just kind of lights them up one by one. I guess it's so you can make something where you turn a knob and a LED slide bar, slides the LEDs either back and forth or up and down or however you want to do it. But for what they're doing, they just go and have the foot switch create an analog voltage, and that'll go and light up either pin 1, 18, 17, 16, which will then go and set all the relays that you need to have channels 1, 2, 3, or 4 going. And it's the same idea in the triple rectifier schematic, where pin 1 will be active for the channel 1, and then pin 17 will be active for channel 3. It's not clear to me which pin is active for channel 2, but it's you'll find that it doesn't really matter so much. So a key difference between the triple rectifier schematic and the Road King schematic is in the triple rectifier, all the relays are referenced to -3 volts, whereas in the Road King, all the relays are going to be referenced to 0 volts. Moreover, this LM3914 chip, that's referenced to 0 volts in the Road King, and it's going to be referenced to -3 volts in the dual and triple rectifier. You can't, again, they don't show you how it's implemented in dual and triple rectifier, but Some notes I took, these are the voltages on pin 5, the analog input to the thing, for the different channels. Okay, so that shows you how it goes and closes all the different relays for switching the different channels. And you can, if you have this schematic, you can go back and see what all those relays change in the audio path and how that gets you the different channels. So let's talk about their mute circuit now. Their mute circuit is triggered when the relays change state. So your typical relay, like this one over here, relay 5, it has a diode that goes back across the relay. So when the relay's on, current's flowing through it, and that activates the magnetic part of it, closes the relay. Now when you turn the relay off, it's a coil of wire in there, essentially an inductor, and that the current that's going through there, it's not going to just stop. It needs to go somewhere when the relay's turned off. So you put a diode across it, and now the current will just kind of circulate between this diode and the coil itself, and that'll shut that relay off eventually. Basically, you're putting a diode drop of voltage across the relay to reset it, to bring the current in it back to 0. So that's your typical relay schematic. That's what most people do with relays to protect them and to get them to turn off. So what Mesa's done with their channel switching thing, you can see there is a diode across relay 4, but it doesn't connect back to the input of relay 4. It connects over here to this mute pulse bus and uses that to go and trigger this BJT, which then goes and closes all of these mute switches. So using the relay reset voltage when it opens, that's not something that's typically done. In this case, it works out. That part of the circuit is just fine. It's a little bizarre, but nothing wrong with that. You could certainly use that to figure out when your relays have changed state and when you would need to go and mute the audio path. Where things kind of go off the rails for them is this J175. This particular part is not quite good enough to do what they want it to do. So this part is some sort of P-channel FET, probably 2 of them back to back, so that way it forms a full switch. And they go and put it across the audio path. When you take the gate of it and pull it down to -3 volts, the FET will be on and will mute the audio path, and then it's allowed to float back up to +15 volts. And when the gate's at +15 volts relative to the audio path, the FET will be off, and it won't be muted anymore. So that idea is fine, but how they implemented it is not fine. Reason being, this J175, if you look at the datasheet for this part, it has a on resistance of over 100 ohms, maybe 150 ohms. And while that seems like it should be low enough to mute something, especially when all the pots are like 1 meg or 250K, it's just the resistance of it is too high to effectively mute that. You can see that if you take the volume knob for the thing and turn that all the way down, and then measure the resistance of the volume knob, that's still like 20 ohms. So muting it with 100 ohms, it's not even as good as turning the knob all the way down. So the mute switch in the mod that I've made, it has an on resistance closer to 10 ohms, which, as it turns out, is good enough to go and mute it. The other place where it goes wrong for them with this mute switch is where they've decided to go and ground all these J175 components. You have to be very careful about where you choose to ground them. So Let's go back up to something on the audio path. Or perhaps we can go down to something on the audio path. Okay, let's look at this one right here. So this is going to mute after all the channel masters, which is basically the input to the phase splitter. Now if you want to go and mute the input to the phase splitter, the phase splitter is referenced to this node right here, basically the bottom of this 4.7K resistor. So that mute switch needs to be connected from right here, the lead on this capacitor, to the bottom of this resistor. And if you don't connect it like that, then just turning the mute circuit on itself will cause a pop. And that's what I found testing out the mute circuit that they had. I went and tried just activating this without having any of the relays switch, and found that just turning on the mute circuit causes a pop. So when the circuit that's supposed to prevent a pop causes a pop, that's a problem. So now let's talk about what the mod does. So what the mod does is it looks at the outputs of this LM3914. All it cares about is whether these outputs change state or not. And if any of these change state, that means that somebody stepped on the foot switch and that we should go and activate the mute circuit for 10 milliseconds. Just because that's how long it takes for the relays to go and change over. And also, that's too short for you to notice as you're just sitting there listening to the thing. So okay, if any of those change state, it's going to go and mute the audio path for 10 milliseconds. So over here in the triple rectifier schematic, let's go and look at where we go and mute the audio path. The first place we go and mute it, as mentioned earlier, is right across the phase splitter. That makes it so it doesn't matter what's going on upstream of this. If you mute it going into the phase splitter, you've muted it for the entire power amp, and that just has you covered. So okay, that's everything in the audio path we've now muted. But as it turns out, there's a back door into the phase splitter, and that's over here through this capacitor on the negative half of the phase splitter. And there are a couple of things that you have to do to go and prevent that. First, you have to go and install a 2 meg resistor from here to there. So that's right across this relay. The reason you have to do that is this node right here is sitting at 15 volts DC. And when you first turn the amp on, this node down over here will be at 0 volts. So the first time this relay goes and closes, you apply a 15 volt step to this node right here, and that's a massive signal to go and apply there, and you get a huge pop. So in the video that I took, the first time I change over to the clean channel, that's easily the loudest pop that you hear. And that's why you hear it. It's this node going from 0 volts all the way up to 15 as soon as the relay closes. So I tried a 2 meg resistor. A higher value might work as well. I wouldn't go any lower than that because you might start to affect the tone by having the feedback path in the circuit on the red and orange channels, which that wouldn't be desirable. But I found 2 meg, that doesn't affect the tone. Okay, so that's one way to get into the back door of the phase splitter. The other way is through the presence relays on channel 2 and 3. So here we are, the presence relays for channel 2 and 3. right here and right here. And this goes right to the negative input of the phase splitter. So whenever these relays change over, you can get another pop. And I found that you can eliminate most of that by putting a mute switch across the tone stack. Basically mutes the inputs to both of these relays, which makes it so when they change over, they're changing from 0 volts to 0 volts, and it's not as big an issue. That was somewhat of a trial and error process, but I found that it does work well. So the path that they're taking is, here's the forward audio path that goes into the positive input of the phase splitter. And it comes through this RC into the presence, and that then gets coupled through here and back over to the negative input of the phase splitter. So that's where the last two mute switches go. They go across the tone stack like that. Now, I suppose you could argue that you could also put it just across the entire master pot. But if you look at how the thing is laid out, where all the knobs are, it's just easier to get to this node and that node. So that's one side of the treble and then the other side of the mid. They're right next to each other. They're on the top row. They're easy to get to.